Okay, so hi everyone. So today in this video we will be discussing about this interesting problem from USACO's gold module that goes by the name why did the cow cross the road 3, right? So this problem will utilize the concept of segment tree, and if you know how to do point update and range sum query, then you are good to go with this problem, right? And before starting the problem, if you have not yet subscribed the channel, please consider subscribing it because I have already created a lot of amazing videos here, as you can see, and I'll be uploading more and more videos in the future related to segment tree and other harder topics. So yeah, if you have not yet subscribed the channel, please subscribe it. Now let's get back to the problem. The problem reads like this, that the layout of Farmer John's farm is quite peculiar, with a large circular road running around the perimeter of the main field on which his cows graze during the day. Every morning the cows cross this road on their way towards the field, and every evening they all cross again as they leave the field and return to the barn. So as we know that cows are creatures of habit, and they each cross the road the same way every day. So each cow crosses into the field at a different point from where she crosses out of the field, and all of these crossing points are distinct from each other. So Farmer John owns total n cows. So this farmer has a total of n different cows, conveniently numbered from 1 to capital N. So there are precisely 2n crossing points, right? So total of n cows and thereby a total of 2n crossing points, that is a entry and exit point for each of the cow around the road. So Farmer John records these crossing points concisely by scanning around the circle clockwise, writing down the ID of the cow for each crossing point, ultimately forming a sequence of 2n numbers in which each number appears exactly twice. He does not record which crossing points are entry and the exit. So now, looking at his map of crossing points, Farmer John is curious how many times various pairs of cows might cross paths during the day. And he calls, so this line is very important, please see this carefully. So he calls a pair of cows A, B as a crossing pair if cow A's path from entry to exit must cross cow B's path from entry to exit, right? Please help Farmer John count the total number of crossing pairs. So in the input we will be given an integer n, that is the total number of cows, and then 2n lines describing the cow IDs for the sequence of entry and exit points around the field. And in the output we just have to print the total number of crossing pairs. So this is our input. So for this given input, let me zoom this a bit. So our n value is 4, that is there are total of 4 cows, and since there are total of 4 cows, then it means that for each cow there will be 2 points, that is one entry point and other one is the exit point. So a total of 8 points given, right? So as you can see here that these 3 can be the entry or the exit point for the third cow. Similarly, this 3 can also be the entry or the exit point for the third cow. So if this is the entry point, then it will be the exit point and vice versa. And the same thing is given for every cow from 1 to 4. And the expected output for this example is just 3. So this is the question. So let us now go to the blackboard and try to understand what does this question is trying to tell and how the output is coming 3 for this example. So let us now go to the blackboard. Okay, so this was the example given in the question, right? There are total of 4 cows in this example, and since there are 4 cows, we are also given 8 distinct points in total, and the expected output for this example is 3. So let us first try to understand that what does this array represent here. So this array represents the order of the cows on which they will enter the field one by one and leave the field. So there is some kind of field on which the cows wants to graze, right? That is graze the grass or something. So this 3 means that initially the field was empty, right? But then this third cow enters the field. Similarly, after this third cow, this second cow enters the field. And after this, the fourth cow enters the field. So at this point currently, if I say, then third cow is present, 2 cow is present, and fourth cow is present, right? And then after this, the fourth number, that is the fourth cow, is also written again in the array. So Since we already encountered 4 and there is 4 once again here, so we can imagine it something like whenever we will encounter a number for the first time, so we will interpret as that cow will be entering the field for the first time. And similarly, when we will again encounter that number which we have already encountered before, then we will interpret this second time number as the cow will be leaving the field at this time, right? So for this we will interpret this element like the entry point for the fourth cow, and we will interpret this point as the exit point for the fourth cow, right? So that's why when I was standing at this point, we had third cow, second cow and fourth cow in the field. But as this fourth was written again, so we interpret as that this fourth cow will now leave the field. So this fourth cow will now leave the field and only third and two cow will remain. So now this fourth cow will leave the field. And now after this, we are present at this element. So at this element, since first is coming for that first time, then I will write here 1. That is, in this field currently there are 3 cows, that is the third cow, second cow and the first cow. And similarly, if we move forward now, that is at this element, then we encounter third cow. But since we have already encountered third cow before, it means that at this point the third cow had entered the field, right? But now at this point the third cow is trying to exit the field. So now this third cow will exit the field. So after this only 2 and 1 will remain, right? And now if we move forward, then we'll be standing at this point. So the cow number that is present at this index is the second cow. But since we have already encountered 2 before, then it means that the first time when we encountered 2 was the entry point. And therefore the next time we encountered it is the exit point for the second cow, right? So that's why this 2 will also now exit the field. And finally, when we will move to this point, then it is equal to 1. And since we have already encountered 1 before, then it means that that before point was my entry point for the first cow and the next point is my exit point now. So this one will also exit the field now. That is returned to the barn from where they had come. So this one is also gone now. So in this way, each of the cows, that is first cow, second cow, third cow and fourth cow, entered this field one by one and then moved out one by one. So initially the field was empty, and after this array operation has been performed, the field is again empty. So I hope you have understood how this array is actually working in terms of field, right? So now let us get back to what the problem actually wants us to calculate. So the problem wants us to calculate this integer. But wait, what is this integer actually? So if you have read the problem correctly, then here the definition of that integer is written. So we have to output the total number of crossing pairs. So that's why this integer represents nothing but the total number of crossing points, or rather crossing pairs, right? So what does this total number of crossing pairs or this crossing pairs mean here? So the definition of a crossing pair is written something like, he calls a pair of cows A, B as a crossing pair of cow. So two different cows are called as a crossing pair if cow A's path from its entry to its exit must cross cow B's path from its entry to its exit. So it might be a little confusing for you at the first glance. So let me explain you the same thing in the board only. So suppose I am talking about a cow. Let's say I'm talking about the xth cow here and the yth cow, right? So suppose the entry point for the x cow and the y cow are like, it entered the field, that is the xth cow entered the field at A time, and similarly the y cow entered the field, let's say at C time, right? Similarly, if I want to write the time at which this xth cow left the field, then let's say it was B. And similarly, if I want to write the time at which this yth cow left the field, then let's say it is equal to D. So I hope you understood this. So this xth cow entered the field at Ath time and left the field at Bth time. Similarly, this yth cow entered the field at cth time and left the field at dth time. So according to question, these two cows will be called as an intersecting pair if and only if the following condition holds. That is, A will be less than B, right? But before the xth cow left the field, the yth cow enters the field. That is, this C will be less than B, and then D will be here. So this is not very hard to understand actually. So what does this mean? It means that when xth cow entered the field here at time A and it is leaving the field at time B, but before actually leaving, the another cow with entry time C actually entered the field. So if this condition holds, it means that these two different cows are actually intersecting pair, and we have to actually calculate these much number of pairs only. So I hope you understood the definition of interfacing here. So in this case we will say that this x and y cows form a crossing pair. That is, these two cows are crossing each other's paths, right? So this x cow and y cow are considered now as a crossing pair. So let us see now why the output is 3 here. That is how the number of crossing pairs for this example is 3. So as I said that for each of the cow, that is for the first cow, second cow, third cow and fourth cow. So let us see for each of the cow how many crossing pairs will they be a part of. That is, let us first talk about this third cow here. So since this third cow is entering the field for the very first time, this 3 is in the field, and then this 2 will come in the field, and then this 4 will come in the field. But after this point, this 4 will left the field. So the first time we encountered a number, that is the cowth number, for the first time, it means that that cow had entered the field at that time. But if we again encounter that number that we have encountered before, it means that it is now exiting the field at t equal to 4, right? So it entered the field here and then it is exiting the field here. So according to the definition of crossing pair, I told you, so as I said before, that if between this another cow enters the field, that is this condition, then I will consider these two cows as a crossing pair, right? Similarly here, since at t equal to 3, the fourth cow have entered the field, and at t equal to 4, this fourth cow is exiting the field. So we want to calculate how many such pairs are satisfying this condition here. So if you see carefully, then here this fourth cow actually entered the field at t equal to 3. Then the next moment only, that is at t equal to 4, that is the next second or the next minute you can imagine, the same cow exited the field also. That is, in between these, there is no cow present other than the fourth cow, because there is no cow entering the field after t equal to 3. So let me explain again what I am trying to say here. So since at t equal to 3, the fourth cow entered the field, and at t equal to 4, the fourth cow exited the field. So in between these two time intervals, there is no cow which other than 4 which entered the field, right? So since there is no cow other than this 4 in this range, that is between 3 and 4, which entered the field after this 4, so that's why the number of pairs that this 4 will form with that other cow which is not present here obviously is 0. So if I write here, then this 3 will be equal to 0 first. As of now, we have already encountered this cow, this cow, this cow and this cow. And since we encountered this cow for the second time, it means that this cow entered the field and now exited the field. So there is no existence of fourth cow in the field as of now. So this fourth cow has gone completely from the field. So when this next cow will come to the field at t equal to 5, so according to this cow, this fourth cow should not exist in the field at all, because it has already come and left before, right? So this cow will never be able to see the fourth cow. Imagine it something like this, right? So now this first cow has now entered the field, and since this first cow has entered the field for the first time, so there is no problem, right? So we will move forward, and now if we move forward and reach this element, that is at t equal to 6, then at t equal to 6 we encounter the third cow again. But since we have already encountered the third cow at the very start, that is at t equal to 1, so it means that the third cow has entered the field at t equal to 1 and now it is exiting the field at t equal to 6. So since this fourth cow is gone now, let me mark that also. So this fourth is gone completely. So now what I'm saying is we are standing at the sixth index, that is t equal to 6. So since we have already encountered 3 before, so that's why now we want to calculate how many c's are there that can be substituted here in order to satisfy this condition. So since for the third cow here, this a is equal to 1 and this b is equal to 6, right? So this a is equal to 1 and this b is equal to 6. So we want to find how many c's are there that lie in this range that can be substituted here. So since here, as you can see very clearly, that there are actually two elements, that is 2 and 1, that are present in this range that can be acted as C and substituted here in order to satisfy this condition. And if we look in this range, then clearly at t equal to 2, the second cow has entered the field, and at t equal to 5, the first cow has entered the field. So these two cows are already present in the field as of now. They have not exited the field yet, right? So since these two cows are still present in the field, so that's why we will say what? We will say that this third cow here will now intersect and form a crossing pair with this second cow. And also this third cow will now also form a crossing pair with this first cow, just like this. So I hope you have understood why this happened, because what I told you that when we were present at this index, then we just checked that if this cow has previously appeared in the path or not. So we saw that this third cow has actually appeared before at t equal to 1. So since this cow has already entered the field at t equal to 1 and now it is trying to exit the field at t equal to 6, so now we wanted to calculate how many pairs will satisfy this condition. That is, since my a was this 1 here and this b was my 6 here, so we wanted to calculate this c, that is how many, that is our c can lie between a and b only, right? That is our c can only lie between this, that is either 2 or 3 or 4 or 5. But since this 3 and 4 are gone completely and only these 2 and 5 are left, which consist of the second cow and the first cow, that means ki the second cow and this first cow are still present in the field and have not yet left the field. So that's why this second cow will now form a crossing pair with the third cow. Similarly, this first cow will also form a crossing pair with the third cow. So that's why this is forming two pairs actually as of now. So that's why I will add 2 to my answer here. And in this way, the work for the third cow is done now. And since the third cow now has also exited the field, so I will mark this as this. That is, this cross represents that this particular cow is no more present in the field because it has already exited it, as we just saw. And now we will move forward. So now I am standing at this index, that is t equal to 7, which has a value of 2, that is second cow. But since this second cow has already appeared before here at t equal to 2, it means that at t equal to 2 it was the entry time for the second cow, and now at the t equal to 7 it is the exit time for the second cow. That is, now our a is equal to 2 and my b is equal to 7. So we want to find c which lies between 2 and 7. That is, c will lie in the range of 3 to 6. So we have to select c from this range only now. And if you look in this range, then clearly 4 has exited the field already and this 3 has also exited the field already, and only this 1 is left in this range, right? So since this only 1 is left, it means that this 2 will form a crossing pair with this 1. That is, this 2 will form a crossing pair with this 1 successfully. And since only one pair is possible here, so that's why I will add +1 to our answer. And in this way also, this 2 will exit the field now. And now if we move forward, then we will be finally standing at the last index, that is at t equal to 8, which has a value of 1. And since we have already encountered this 1 before here at t equal to 5, so it means that at t equal to 5, this first cow had entered the field for the first time. And then at t equal to 8, this first cow is trying to exit the field now. So since it is trying to exit the field, so now I can say that the value of A here is 5 and the value of B here is 8, and we want to select C, which will obviously lie between this A and B, that is between 6 and 7, that is in this range. But if you look in this range, then clearly there is no cow present in the field as of now, right? And since there is no cow present in this range, this will add a nothing but 0 to our answer. And in this way, finally, this first cow will also exit the field. And if you sum this up, then it is nothing but 2 plus 1, that is 3, which was our expected output. So in this way, we did a dry run completely for each and every element and saw how the output is coming out to be 3. So what are these 3 pairs actually? So the first pair is 2, 1, the second pair is 3, 2, and the third pair is 3, 1. So these are our 3 crossing pairs. And what was the condition of crossing pairs? So this was the condition of crossing pair. So I hope that I was not very fast and you have understood it. And if you have not understood how this output came here, I think you should rewatch the video from the start, because I think by watching the video again you will definitely understand what I am trying to say. So let me now erase the unnecessary things here. So let me summarize this all again, that what I did actually. So in the input we were given n. So in this example the n value was 4, and that's why we were also given with a total of 2n integers. So for each cow here, that is for the first cow we were given 2 points, for the second cow we were given 2 points, for the third cow we were given 2 points, and also for the fourth cow we were given 2 points. So here as you can see that this first was written 2 times, this 2 was written 2 times, this 3 was written 2 times, and this 4 was written 2 times. So the first time we encountered a cow, it represented that that cow has entered the field for the first time at this particular time, that is at t equal to 1, right? And when we again encountered that same number the next time, so that represented the exit time for that particular cow at that particular time, right? So here for the third cow, it entered the field at equal to 1 and then it exited the field at equal to 6. So since the question wanted us to calculate the total number of crossing pairs, so what was the definition of crossing pair if you remember? So if a cow, that is let's say xth cow, enters a field at t equal to a and exits the field at t equal to b, and similarly other cow enters the field at t equal to c and then exit the field at t equal to d, then so for these two cows to form a crossing pair, this condition should be satisfied. That is, before actually the ending of this xth cow, that is before the exit point of this xth cow, the entry point of the another cow should come before, right? So if this C comes before this B and after this A here, like this, then I can say that these two cows are now forming a crossing pair. That is, they are crossing each other's paths in the field, and it will contribute a +1 to our answer. So here we did the same thing one by one. That is, we started from the very start, and since we encountered third for the first time, then we moved ahead. Then again we encountered 2 for the first time, then we moved ahead. Then again we encountered fourth cow for the first time, then we moved ahead. But since we again encountered this 4 which we encountered before already, so I wanted to calculate the total number of crossing pairs between this cow, that is the fourth cow, and some other cows that have already occurred in this range. So since the value of A here for the first cow here is 3 and the value of B here for the xth cow is 4, my A here was 3 and my B here was 4. So since I wanted to calculate C here, that must be lying between this A and B, so it means that this value of C here should lie between what? Between 3 and 4. That is greater than or equal to A plus 1 and less than or equal to B minus 1. That is here in this range. And since in this range, if you see, then there is no element present actually, because these two elements are present side by side, right? So that's why since in this range there is no cow that actually entered the field. So since in this range there is no cow that actually entered the field, so that's why this contributed a 0 to our answer. So in this way the fourth cow entered the field at equal to 3 and then it exited the field at equal to 4. So there is no existence of the fourth cow when we will be standing here. That is, the first cow will only be able to see these two cows in the field because these two have not yet exited the field, but this fourth cow has exited the field. So this will not be present here. So that's why now I am present at t equal to 5. And at t equal to 5, the first cow enters the field. And how we know this, that this first cow has entering the field and not exiting the field? Because we are encountering this one for the first time. So we will interpret the first time encounter as the entry time only for that particular cow. So now currently this cow is present in the field, this cow is present in the field, and this cow is present in the field. And now when we move to this index here, that is at t equal to 6, then it has a value of 3, right? And since this 3 has already occurred before at t equal to 1 here, that means this third cow is now trying to exit the field. So if I write the value of a and b for the third cow here, then clearly a is equal to 1 and b is equal to 6. And now I want to find c, which lies between this a and b, that is between 2 and 5, that is this range, which is nothing but this range only. And since in this range, clearly only the second cow and the first cow is present because these two have already left, right? So since only these two cows are present, so it means that they will form different pairs with the third cow individually. That is this 3, 1 and this 3, 2. So in this way we got these two pairs. And now since 3 has also exited the field, so that's why I will mark it with a cross. So this cross represents that particular cow is no more present in the field. I hope you are getting what I am trying to say. So now after t equal to 6, I am now standing at t equal to 7, which is a value of 2. But since we have already encountered 2 before, so it means that the second cow entered the field at t equal to 2 and now it is exiting the field at t equal to 7. That is, the value of a here is 2 and the value of b here is 7. And since I want to find the total number of crossing pairs, that is, I want to find the number of c's that lie between a and b, right? That is, lie between 2 and 7. That is, c should lie between greater than or equal to a plus 1, that is 3, till less than or equal to b minus 1, that is 6. That is from 3 to 6. That is in this range. And since in this range clearly these 3 cows are absent and only this cow is present here, that is the first cow which entered the field at t equal to 5. So that's why this one will now form a crossing pair with this second cow, which is this. So in this way, this contributed a total of 1 to our answer. And in this way, this second cow will also now left the field at t equal to 7. And ultimately, we will now be present at the last index, that is at t equal to 8, which is a value of 1, which has already occurred before here at t equal to 5. So at t equal to 5, the first cow entered the field and now at t equal to 8, this first cow is exiting the field. That is, our a here now is equal to 5 and my b here now is equal to 8. So since now I want to find c, which lies between this a and b, that is lies between 6 and 7 inclusive, that is in this range. But in this range there is no cow present in the field actually as of now. So since there is no cow present here in the field, so that's why it will contribute a 0 to our answer. So it contributed a total of 0 to our answer. And in this way, the first cow will also leave the field once again. And after this point, my field will completely become empty, right? There is no cow present. So it will be completely empty now. So I definitely hope that by now you have understood what does the problem is trying to calculate and how the expected output 3 is coming for this example here, right? So what we are doing nothing, but we are just trying to find the number of C's which lie between A and B, right? That is the number of cows which have come before this B and is present in the field now and have not exited yet. That is, this C represents the number of cows which have come in the field before this exit point of B and after this entry point of A and have not exited yet. So we just want to calculate those much number of C's only, right? So how we will do this now, and how does the segment tree will help here in this case? Okay, so now let us see what will be our approach to this problem. So here I have considered a map here, that is int comma int. So the first integer will represent the time of entry, and the second integer will represent the time of entry for this particular cow, right? And also if you see, then I have considered another array here which is of the exactly same size as the input array, right? And since in the input we will be given a total of 2n integers, since the value of n is here is 4, so here 2n will be equal to 2 into 4, that is 8. But if I do it in 0 based indexing, then clearly I will only be able to access this from 0 to 7, that is from t equal to 0 till t equal to 7. But for our understanding purpose, since it is easier to imagine in terms of 1 based indexing, that is the third cow entering at t equal to 1 and the first cow exiting the field at t equal to 8, right? So it is easier to imagine in 1 based indexing rather than the 0 based. So that's why I have taken the size of this initial array to be actually equal to 2n plus 1 rather than 2n, so that I can easily access the indexes from 1 to 8 easily. So this array that I have considered here is same size as this array, right? And what does this array represent here? This array represents that at a particular t here, that is t equal to 1, t equal to 2, t equal to 3 till t equal to 8 here, that particular element value will represent how many cows have entered the field at that particular time. So you might not be understanding the significance of this array, but you will soon realize. Just be with me. Let us now again start our procedure and see how these two things will help us in actually calculating our answer. So now I am standing at the first index here, right, which has a value of 3. And since I am encountering this 3 for the first time, but how I will know this, that this third is being encountered for the first time here, but at this point this third is being encountered for the second time. So in order to know that whether the cow is visiting a field for the first time or not, I will just use this map only. So what I will check that if my map of this third is actually null or not. So if this MP of 3 will give me a positive value, it means that this third cow has already entered the field before. But as of now, since our map is completely empty, then it will tell me that this third cow has not yet entered the field, and thereby it is entering the field for the first time. So since it has not entered the field yet, so that's why I will write here that this MP of 3 is equal to 1. And sorry, I think I actually told you the opposite meanings of these two integers here. So this first integer actually represents the cow number, right? And this second integer actually represents the time at which that particular cow is entering. Now since I encountered this third cow for the first time, and how we interpreted this? We interpreted this by looking in the map, because initially my MP of 3 was a null value. There was no positive value for MP equal to 3, MP of 3, right? So this map is helping us in order to determine whether we are encountering a particular cow for the first time or the second time. So this is the importance of map here only, right? Okay, so since we encountered this third for the first time, so we included it here in the map. And now since I have encountered a total of 1 cow at t equal to 1, this is the status of my array. That is, since each and every element here is equal to 0, it means that there is no cow present in the field as of now. But since I have encountered 3 here and have added to the map here, that is, this third cow has now entered the field. So since this third cow has now entered the field at t equal to 1, so I will say here that at t equal to 1 it will no longer be 0 but rather 1. That is, at t equal to 1 there is some cow in the field which has entered. And now after doing these two operations in the map and this array, I will move forward, and now I will be standing at this index which has a value of 2. And again if I look in the map, then MP of 2 is null here. That is, there is no value for MP of 2 as of now. And since there is no value of MP of 2, so it means that I am encountering this 2 for the first time. That is, this second cow is now trying to enter the field for the first time, and thereby I will add to the map. So I will write here that MP of this 2 here will be equal to what? It will be equal to 2 only. That is, the second cow entered the field at t equal to 2. And since at t equal to 2, cow has entered the field, so I will erase this 0 here and instead I will write 1. So this represents here that at t equal to 2, some cow has entered the field, right? Now I will again move forward. So now I will be standing at this third index, which has a value of 4. And since it has a value of 4, which has not occurred before, and we will know this by using the map. So since in the map there is no value for MP of 4 as of now, so that's why I will write here MP of 4 equal to this 3. That is, I have encountered the fourth cow for the first time at t equal to 3. And since I have encountered this cow for the first time at t equal to 3 here, in this array also I will say here that at this t equal to 3, a cow has entered the field. So 1 here like this. And now I will again move forward. So now I am standing here, that is on this index, that is at equal to 4. And now if we check if this element is present in the map or not, that is MP of 4. And if we check, then clearly MP of 4 is a positive value here, which is 3. So in this way, using the map, we are able to determine whether this 4 has previously come or not. And since it has already come before, it means that now this is not the entry point but rather the exit point. And since it is the exit point here, so it means that this is our A, this is our B, and I want to calculate the number of C's between this, right? That is, my A here is 3 and my B here is 4, and I want to calculate C in the range of 4,3. That is in this range. That is the number of cows which entered the field after t equal to 3 and before the entry of this fourth cow, that is t equal to 4. But since these two elements are present side by side, that is at a moment of 3, this cow entered the field and the very next moment this cow exited the field. So it is not possible for any cow to enter the field in between, common sense, right? So that's why it will be 0. And here also if you see in the array, then what we wanted to calculate? We wanted to calculate the number of cows which have entered in this range. But when we will pass 4,3 to our query in order to calculate this range sum, then we know that our L can never be greater than R. So it will obviously return 0. So that's why this will contribute 0 to our answer, right? That is, this fourth cow will never form a crossing pair with any other cow. So that's why 0. And once this has been done, what I will say that okay, now we have got our answer for the fourth cow, which is 0, and this fourth cow will now want to exit the field. So since this fourth cow will now want to exit the field, and whatever the next cows will come after this fourth cow, they will never be able to imagine the existence of this fourth cow. Why? Because it has already exited the field. So it would be better for us if we just erase the existence of 4 from both of these data structures. So that's why, since we don't need the information of 4 anymore for the next cows, so that's why I will say here, since before at t equal to 3 this 4 has entered the field, so that's why at t equal to 3 here I have marked here 1. That is, the fourth cow entered this field at t equal to 3. But since it has now exited the field, so I will say here now that this 1 will no longer be a 1. So it will be 0 again, because the fourth cow has now exited the field. Similarly, we will also erase its mapping from the map, because we don't need the information of this 4 anymore. If you want to, you can just keep it here like this. It will not affect anything, right? Because it will not be used anymore. But if you want, then you can obviously erase this information. It is not needed anymore. Okay, so after doing this, what I am saying is we are standing at this index by transitioning like this. So I am standing here, and since I am standing here, which has a value of 1, and when I looked in the map, then clearly there is no value with MP of 1. That is, MP of 1 is null as of now. That is, this first cow is now entering the field for the first time. So that's why, since it is entering the field for the first time, so I will mark its entrance here. So I will say that this first cow has entered the field at t equal to 5. And since it has entered the field now, so I will also update the status in this array. That is, this first cow has entered the field at t equal to 5. So at t equal to 5, it will no longer be a 0 but be a 1. So what does this 1 represent? It represents that at t equal to 5 there is some cow that has entered the field and is present in the field as of now. So after doing this, I will move again, and now I will be standing at this 6th index, which is a value of 3. And now since this is a value of 3, so now I will check whether this 3 is the starting or the exit time for this third cow. That is, I will check MP of 3. And since this MP of 3 has already a positive value here, so it means that this 3 has already occurred before. And since it has already occurred before, so now my A is equal to what? This 1, that is this MP of 3, and my B is equal to where I am currently standing, that is 6. And for this too, I want to find the number of C's which lie in this range. That is the number of cows which have entered the field during this time. And also I forgot to mark one thing, that this 4 has already exited the field, right? So mark them. And now what I'm saying is I want to calculate the number of C in this range, that is from 2 to 5. That is the number of cows which are present in the field as of now and have not exited yet. That is between t equal to 2 till t equal to 5. That is in this range, right? And if you look in this range, then at t equal to 2 it has a value of 1, and at t equal to 5 it also has a value of, it means that there is some cow that has entered the field at t equal to 2, and there is also some cow that has entered the field at t equal to 5. So a total of 2 cows here. That is the range sum of this. So since there are a total of 2 cows here, so we will add +2 to our answer. In this way, what I will do now, after doing this, this third cow will exit the field now, right? So this third will exit the field. And since this third is exiting the field, so whatever cows will come next, it will not be able to determine whether this third was present before or not, because third has already exited the field now. So that's why it means that I have to erase the information from this map and from this array also. That is, since this third cow entered the field at t equal to 1, that is at this instant, so that's why at this instant I will mark it as 0 here. So this will be 0 now. That is no information related to any cow that entered at t equal to 1. Simple, right? And now I will again move forward. So now I am standing at this 7th index, which has a value of 2. And now if I look at MP equal to 2, that is MP of 2, then it is clearly a positive value here. It means that this 2 has already occurred before. At what index? At the 2nd index here. So that's why I will say now that my A value now is 2, that is this, and my B value is now where I am currently standing, that is 7. So my C would lie between 3 and 6. So now I want to find the number of C's in this range, that is the number of cows that have entered the field in this time, that is between 3 and 6, that is in this range, that is this range. So since in this range there is only one element present here which has a positive value at t equal to 5, so it means that at t equal to 5 there is some cow that has entered the field and have not yet left. So since the range sum of this is just 1, so that's why it will contribute a +1 to our answer. So in this way, this 2 will be processed, and hence this 2 will exit the field now. And since this 2 will exit the field, it means that whatever cows will come next, they should never know the existence of this 2 anymore. So I will erase it from the map here, and also I will erase the time at which this 2 actually entered the field. So since this 2 entered the field at t equal to 2 only, so at this t equal to 2, it will no longer be 1 but 0. And now finally I'll be standing at the last index, that is 8th index, which has a value of 1. So I will check here, what is this MP of 1? So this is a positive value. It means that we have already encountered this 1 before somewhere. And since we have already encountered it, it means that now this first cow wants to exit the field. So now I can say that the value of A here is this 5, right? And the value of B is wherever I am currently standing, that is 8. And I want to find the number of C's that will lie between 6 and 7. That is this range, that is this range. But if you take the range sum of this here, then clearly each and every element here is equal to 0. That is, you will not get any cow that has entered the field at either t equal to 6 or either at t equal to 7. So no cow entered the field during this interval. So that's why it will contribute a total of +0 to our answer. And finally, after doing this, this first cow will leave the field like this. And since it has left the field, it means that this first cow will not exist in the map anymore. But erasing this information from the map is optional, as I have already told, because even if you don't erase it, then it will cause no problem because it will not be used again, right? But for the simplicity purpose, I have erased it every time. And also I also have to update the status in this array for this first cow. So since this first cow entered for the very first time at t equal to 5 here, that is at this point, which is 1 here as of now, so I will erase this one and I will write a 0. That's why now if you see, then after each and every cow has been processed and left the field is empty, and so that's why our array has also turned out to be 0 completely once again, just as it was initially. So in this way our whole approach will be done, and now I think it would be very better for us if we actually move to the coding part and actually code this up, and then you will understand each and everything how this is performing under the hood. So let us now go to the code editor and actually code this up. So in the input, if you remember, then first we have to take the input of n, and then we have to take the input for 2n integers. But as I told you that we will only be using 1 based indexing everywhere, so that's why instead of using a total size of 2n, I will actually be using a total size of 2n plus 1. And now I have to take the input for these 2n integers, starting from I equal to 1 and going till 2n, like this. Like this. And once the input for every 2n integers is done, what we have to do next? So as I said before, I will declare a segment tree here. Let's name it as small t, and I will just pass the size of this nums array, that is 2n plus 1. So let me paste my standard segment tree template here. So this is my standard segment tree template here, but in this template, as you can see that in the input here I am passing the size, but in this template I used to pass the actual vector. So this is now what? This is my size here. Let's say it as capital N. So this will be equal to now this, and this array will now be equal to what? So this I will have to resize this array, right? And this will be enough. So I will say here that arr.resize this total size equal to 0. So what does this statement is doing here actually? So this statement is responsible here for creating this array here with each and every element equal to 0 initially. So once we have done with this, then let us move forward. So after the segment tree has been declared, what I told you next, I told you to also declare a map here. So I will be using here an unordered map, and it will be of int comma int only, right? Let's name it as mp, and since I have to store my result also in some variable, so I will store it, let's say, in a variable named as result, res. And now let us actually start our traversal across the 2n integers, that is this nums array. So I will say, so this I represents what? So this I is equal to the time. And what is this nums of I? So this represents the cow ID, that is nums of I. Now there can either be two cases, either we are encountering this cow for the first time or the second time. So if we are encountering it for the first time, then I will say that if this mp.find this cow ID is equal to mp.end, it means that we are encountering it for the first time. So I have to update its information in both the map as well as the segment tree array. So I will write here that this cow ID is present at this time, that is I have encountered this cow at this time. And also I will say that t.update at this time I encountered one cow. So this. And if this is not the case, that means the cow is being encountered for the second time, that is during the exit time, right? So before this was my what? This was my entry time, right? And now it is my exit time. So during exit time, what we used to do, we used to actually find the time at which that particular cow actually entered the field for the first time. So I will say here that time of entry, so this will be equal to what? So this will be equal to nothing but this MP of this cow ID, right? So this will give me the time of entry of this cow. And if you remember, then what we used to do next? So in the result variable, I will add the answer of the query. In which range we used to check? We used to check in this time of entry plus 1 till this I minus 1, right? So this will give me the total number of time intervals or time movements at which the cows have entered the field and have not yet left before the exit of this current cow. And once this has been added to our answer, this current cow, that is this I, will also leave the field after the answer has been calculated for this particular cow. So I will say here that t.update. So what we have to update? We have to update the entry time equal to 0 now, right? That is this time of entry. So what is this? This is the index, right? So we have to set it equal to 0 now. And also we can also erase the information from the map, that is mp.erase this cow ID, because this cow now has left the field successfully, so we don't need its information anymore. And once this is done, we just have to print the result like this and return. So in this way, I think the whole code will be written, and let us run the code to see if this is working fine or not. So as you can see that we are getting correct answer for this test case, right? And if you remember, then we have to submit this solution in the USACO website, right? And in the USACO website, if you read carefully, then clearly here in the input and output file name should be like, it should be circle cross dot out, right? So that's why I will write here, instead of this input and output, this. So now if I try to submit this code, let's see. So we will be submitting this in C++ 17 only. So let's submit this now. So as you can see, we are getting correct answers for each and every test case here. So I really hope that you have understood this problem very well, like how we use the simple concept of range sum and point update in order to solve this problem. And if you are still watching this video and have not yet subscribed to the channel, please consider subscribing it, because it takes a lot of efforts to create each and every single video for you guys. So yes, if you have not yet subscribed, please consider subscribing it and share with your friends who need to watch this series in order to gain confidence in this topic. So yes, thank you so much for watching this video. Thank you.